corporations, some of the policymakers of some countries in understanding the trend in different areas, the technology trends. So let me just, so what I'm planning to do is that just to expand from there and look at some of the technology forecasting methods. Okay, so here are the topics. So the first of all, we will look at the significance of technology forecasting for different areas, for example, like, including national level and the different levels. And then what are the factors that are influencing technology forecasting? Again, there are different types of methods. So we will go through a couple of them, Delphi method and the growth curves related ones in more detail. And then I'll be spending more time on mining technical documents for technical forecast. So that is where my experience is, and our product is also in that area. And after that, like, we will summarize. Again, I encourage everybody to ask questions in between as we go through, so that we are all in sync on the topics. Okay, so here, if you look at the significance at the national level, you know that like, developing the technological competence is one of the major areas at the national level. Like, for example, if you look at China, so they are doing a lot of work in the artificial intelligence area, for example. Like, so they are improving the competitiveness in that area. And similarly, I'm sure that in India also, as I don't have all the different countries top priorities, but so this is one of the top areas for country level. And then there is a sustaining a competitive edge in selected technologies. For example, like, there are countries where they are very strong in automotive area, for example. They want to keep it that way. When a technology changes, like, when combustion engines move to electrical motors, right? So they still want to keep the competitive edge. So they look at, what are the technical changes that are coming up, and they forecast for that particular purpose. And the other one is planning for the use of technological innovation for citizens. For example, I understand that in Kerala, we have blockchain. Like, we are trying to use blockchain for different purposes for the citizens over there. So these are different. Some of the use cases at the national level. Again, this is a very well-known quote: "The only way to get sustained faster growth is to have sustained faster technological progress." Again, from Robert Soloff. So this, everybody has taken this to heart, and even at the country level. So so basically, this is technology is the main focus in many countries because of the same reason. Okay, so here are some of the items from the business level. So this is where I have been working a lot. For example, if you look at the first one, is like identifying and assessing what are the opportunities or threats in an area. So that's the reason most of the corporations are continuously looking at the new technologies that are coming into the market, and I will go through the details in one of the later slides, actually, on the growth curves. I will go through that in detail. Okay, the other one is like here, minimize the surprises. Like, many times, technologies change, like technologies grow, and for the same industry, a new technology comes in, and older companies go down, and newer ones come up. So these type of surprises are coming from this disruptive innovation. I will show you what is the meaning of the disruptive innovation and how it impacts larger companies as well as smaller ones. Okay. And so the other one is that allocating resources in R&D. For example, like, we have worked with the companies where there is an R&D center, and they want to know what would be the upcoming technologies, and they need to move the resources in that direction. And so the first one will be the R&D, and the second level will be the product development part of that. That means whatever they are developing, the R&D center will be moved to the product development side. So this is a critical part in most of these corporations. And the other one is timing of new product development. Again, this is coming to that. Like if you develop a product that is too early for the market, again, that is not going to be successful. So basically, to find out the timing, again, technology forecasting is important. So now coming to the next one, like, many times as the technology move, many corporations, they come up with the joint ventures with the different other players in the field. So that way, you may see computer companies having joint ventures with automotive companies, or AI companies with automotive. So this way, there will be a lot of alliances and joint ventures happening within the corporate world. And so the last one over here, again, this is not the last one. There are many, but here is the divest, or if there is a new technologies coming and your technology is going to be like going out of style, then you need to change the direction in which you are going. So you might need to divest some of your technologies, or you need to commercialize that and give it to the right direction, so that you can focus on your area. So this is another one. So for this also, you need to know what is happening, what is going to happen in the technology area. So these are the major reasons for technology forecasting within a corporate. Okay, so here I'm just talking about little bit about the communities level. Like whenever there are technology forecasting, based on that, there will be interactions between academia and industry. For example, whatever is coming up in academia, industry will be ready to take it, or industry will be pushing the academia for getting newer work to be done in the area. So there will be a lot of interaction between them, and also science and technology. Like most of the many times science, scientific research is being converted into technology and products, and going to the market. Then industry and politics, for example, or here. So if you look at when it comes like the government level, they make policies. So based on the policy, those policies will be pushed by the industry. So basically, there will be a lot of interaction between industry and politics, and again, technology and public, depending upon whether the technology is ready for the market. So basically, this is just showing that there are different levels of interactions between different communities in the academia, industry, between science and technology. These are all happening again for this same reason: technology, based on the technology forecasting, based on the way the technology is changing. So these are some of them. Now, coming to the factors that are influencing technology forecasting. The most important thing is availability and again accuracy of the data. And now, if you look at in many areas, there are a lot of experts in that field, but those are all subjective, right? So whenever you are taking in a forecast in a technical area, you need to make it as less biased as possible, and so just having the availability of data, or having the availability of experts is not sufficient actually. So you need to look at other areas like the technical documents. There will be a lot of documents. For example, if you look at the patent documents itself, there are 130 million plus patent documents itself, and then there are scientific documents, more than that scientific documents. So if you look at any development that is coming in a technical area that are on the top of whatever is already existing. So now the question is that, can you get those knowledge from those technical documents or knowledge from those experts, and so that you can use it for forecasting the next big idea. Okay, so again, availability and accuracy of data is very critical. The other one is that factors like influencing the technology itself. Again, here factors influencing technology forecasting, and here we are looking at influencing the technology itself. For example, developments in related technologies. If you look at interdisciplinary area of research is increasing day by day. Because so that way, if something happens or if some new inventions happening in a new area, so that has a lot of that might affect many other areas as well. Okay, so developments in related technologies will will have an impact on the current technology, whatever you're looking at, and again market readiness. So there are too many factors over there, and again government policy. So there are two things. One is that if the technology is moving in a direction, the government policies will change in that direction. At the same time, the government takes a policy in a direction that will influence the technology aspect. So there is an interdependence between the technology forecasted as well as the result of that. That means the change in the policy. So that the interaction is always there. So that's why it is a little complex to come up with a forecast and to make it ready. Make it true for a longer period. Again, assumptions on technology trajectory, so if you look at the many times the technology will be evolving. There will be smaller changes. There's a new product, you got a new product. In the next maybe a few months or years, the product will be becoming better and better, and then after some time, there will be a new product or new technology will be coming into existence. At that time, this continuous change on the product will be changed to a completely discontinuous one. That's when the disruptive technology is going to appear within that area. So I will go through that one in the next one through some of these S curves and all of that. Okay. The other one is that like a pattern of growth. For example, we may assume that the development of a technology is going to take an S curve, in the form of an S curve. Again, S curve means initially it is slow and then it picks up steam and then slowly taper off after some time. So again, these are all assumptions, or these are some of the patterns that we are assuming whenever we are making a technology forecast. And then another thing is that there are different metrics, for quantitative measure. If you're looking at patent data or technical documents, and one measure is, okay, how many new publications are being published in that particular area. That shows that whether there is a growth, there are more researchers are getting interested, or if there are more patents in that area, that means there are more companies are getting into that, and they are trying to commercialize that particular technology. So again, there are different types of metrics. Again, that is also important point. Okay, here technology forecasting methods. There are multiple ones, but again, explorative as well as normative. These are the two most important ones. And again, there are combinations of both, and some of them take some of these differently. For example, some of them called intuitive as a separate one. Okay, so let me just put it into two categories. One is that explorative. That means basically the assumption is that we are starting from today. What do we know today? What do we have today? And then try to find out what are the possible outcomes that is going to happen in the next few years or next few months. Again, there's a time frame. Again, that whether it's a short or long, medium or long, those are all different parameters. So the idea is that you start from whatever is already known, and then almost like for the future. And again, give a quantitative measure of what is the probability for that to happen, or so that's how it works. The normative is on the other side. You come up with a future goal or a mission. Again, this mission can be sometime back, John F. Kennedy over here.
Based on that online programming.
Okay. Yeah. Let me know if you have any questions. Like, you know, if when he announced that he was going to send a man to the moon, again, immediately the technology related to that immediately changed, right? So basically, once we have a mission, and then we start from like, you know, work backwards. You know, what are the things that are required to reach that particular mission? Okay, so these are the two different ways. So we will be focusing more on the exploratory side, because, you know, most of these are the areas where I'm going to spend more time on. Okay, so in the explorative case, there are the first one is intuitive. Intuitive, like, you know, as we were talking, there are many experts in every field. Now, can we make use of their intuition to come up with a forecast for a technology? So that's what this intuitive is. Again, we'll get into the more details with the Delphi method. And the second one is a growth curves. Again, like an S curve, and how like in a different phases of that. We'll go through that. So these two I will go in more detail. The other one is a data and text mining. So data mining in this particular case is like, you know, whenever there are technologies explained within documents, scientific documents, patent documents, even if that is explained inside, how do we find it out? How do we know that, okay, if there is a AI related method inside, you know, how are we going to find it? Or we need to mine it, and we need to build a case with that. Like, what are the different technologies? Identify that, distinguish that, and then come up with an estimate, or, you know, a forecast. So we will spend some time on this. Bibliometrics means, like, you know, in patent data, like, you know, there are citations and different publication, like a number of publications and all of those. And the trend extrapolation means that we can tell what happened so far. Like, you know, after that, we need to extrapolate that. Like, we can use a different types of assumptions. Like, okay, it's a linear extrapolation. Like, if it happened so far in a particular direction, again, we are going to think that, you know, the same linearly it is going to go to the future. Okay, so the other one is that analogies. Like, you know, in this case, I'm writing TRIZ. So TRIZ is something like, you know, so there is an assumption that how the technologies grow. Like, you know, so basically using that particular pattern, we are assuming that other technologies will also move in the same direction. Again, like, you know, this is another method. So these are some of the simple explorative forecasting methods, and the other ones are like, you know, normative relevance trees. Basically, you know, if you have a mission, if you have a goal, you look at all technologies that are related to that, or that will have relevance to that, and then you build a tree from, like, you know, so starting from the top, you know, you find out, you know, what are the things that will impact that, and then slowly build it all the way down. And so that's the relevance tree based. And morphological analysis is like, you know, you look at all problems and solutions and find out, like, you know, what are the things to be solved in order to reach the particular goal. Like, you know, so that is a little different way of looking at it. And mission flow is like, and if you have one way to do, you look at different ways to achieve the same goal. Like, you know, so we are not going to spend time on this. We'll be spending time on mostly on the explorative one, because, you know, that is where our current, I mean, at least my focus is in the technology forecasting. Any questions, let me know. Okay, so let's look at intuitive methods. Of course, we can ask one expert, to get an idea about, you know, what he or she thinks about the future is going to be in a technology. Of course, you will get an answer, but it will be subjective. And like, if you ask multiple experts, you know, you will get you might get different answers. So starting with the one expert is the first one, intuitive method, and the second one is a panel of experts can be there in a panel, and they can come up with a forecast. And the problem is that, you know, whenever you do that, like, you know, those panelists who are very strong, and like, you know, they may push their ideas, and that may come out as a one. So it will be mostly biased, and it will be dependent on the personalities or the panelists. This is the reason this Delphi method is formed. Basically, just to try to get rid of as much bias as you can from the in getting the forecast actually. Okay, so in the case of Delphi method, also there is, again, it's from a group of experts. You start with a group of experts, and then go to them with a questionnaire, or or they can write down their own ideas about what the future is going to be, or they can forecast the technologies, the line of growth. And then what will happen is that a moderator will collect all of those, and then send the collect all the answers and send back to the same team, and then tell them that, okay, this is the distribution of all the answers that we have received, and do you have any do you want to change your opinion, or do you want to change your forecast? And then, so this way it can go back and forth a few times, and then at the end, again, the panel, the moderator can ask, what is the reason that you are changing the responses? So basically, at the end of this particular process, you get to a large extent, unbiased, or at least a statistically more accurate answer to the technologies going to be, right? So this is a Delphi method. I understand, I haven't used this, but I understand that this is the most well-known method in technology forecasting. But this is not what is used from the data side. Okay, so now the other one is growth curve. Again, this will come up again and again whenever you look at the technology forecast. For example, in the first case, okay, I'm going to spend a few minutes on this. So what it shows is that as time progresses, the performance of a technology, or whatever you are trying to achieve, the performance is not going to increase drastically. So basically, that is where the research is going on. And after some time, then there is a inflection point, or at least in this particular case, there's a critical point where it becomes more cost effective, or so this is where it, one second, this is not sure. Okay, so this is where it is growing fast. That means, as time goes, its performance increases. Again, this is evolutionary. So we can, this is we are improving the whatever the process or machines, or whatever we are doing, it is improving the performance of that particular system. And then at the end, the assumption in the case of S-curve is that it will reach a limit. After that, it will stop, or it will come down after that. So as we go here, by doing some work in this area, evolutionary, all the research that is happening, it may go up a little more, or it may go a little more, or it will not reach there. So on an average, it will go from a very slow growth to fast growth, and again slow. Now if you look at the same one, again the same area, there is a new technology is going to come. So what happens in that case is that, so initially when that particular technology is introduced, at this particular point, the existing technology is better in terms of performance. So that is why it is difficult to notice that initially. For example, if you look at all research that is happening in an area, you may see that that research is not bringing results. It is too expensive to build, and all of those. So people may not notice that. And now what happens is that this initial technology, that all technology has a maximum performance up to one particular level, but this new technology can go much higher. Okay? So this is where the disruptive technology, this is what most of the companies are putting their effort. What is the disruptive technology that is happening in their area of research? Or who are the companies that are working, or who are the researchers working in that field? And now, identifying this particular area is a critical one. So it is not a differential, like it is not just a incremental, basically, no, not incremental, but it is a discontinuous one. Okay, so this is what is causing like the larger companies to, like, if they don't notice this one on time, the larger companies might fail, whereas like the newer companies will take over. So larger companies are always looking for, so that they can put effort over here, and like they can ride the next wave, so that the whole evolution will be like so they will go all the way to the top. So this is the disruptive technology, and like and it is difficult to forecast that particular one. But we can, like if you so I'll also talk about what are the different ways that we are doing that. Again, I will show you through some of the products in Relicura. So what we need to do is that we need to keep tracking the technology that is coming up and continuously monitor that, and then it's not like we are not looking at just the efficiency of the product, but if something can solve the similar problem or same problem or similar problems, like that can be captured from the latest publications in scientific as well as in a patent area. So that is something that I'm going to show you through. Okay, so this is just to show that like there's a different types of curves are there. Like in this particular curve, this is a Gardner hype cycle. So there are 2 dimensions here. This is time and expectations, and there's another dimension is the color. Like for example, like if you look at the blue color, that is like 2 to 5 years. That means like within 2 to 5 years, it will go from here all the way to like to this particular level. Okay, so this is the innovation trigger. That means like if you look at another way to look at it is that you can plot this one on an expanded scale or shortened scale, because some of them, for example, the 2 to 5 will pass through this very fast. But if you're looking at these more than 10 years type of one, for example, like biodegradable sensors, I believe here. So if you are looking at that, that is again, it is going to take many years for passing through this particular area. Okay, so this is innovation trigger, then peak of inflated expectations, like and then okay, so again you can read that. Okay, so now let me take you through like the technical documents. Okay, so 2 major corpus of documents are like one is patents, and another one is scientific documents. Patents is mostly related to like industry, most of the time, because whenever you are filing a patent, you are putting some money to that, and you are getting the rights, and so you are investing in that. Okay, and as you know, like you need to patent it in order for you to commercialize that technology also. And the other one is scientific documents. And then in addition to that, there are conference documents and other technical documents are also available. But these are the 2 major ones. Now, if you look at any patent, you will see that there are a lot of complex legal statements inside that. And can you find out what is the technology it is talking about? So that particular part involves a lot of work actually. So whether it is from natural language processing, that means like these are all English language in legal terms, but we need to understand that. And second one is that we need to do a lot of machine learning to understand, even when you say that okay, something is an electric vehicle related document, you need to know what is the meaning of electric vehicle. Is it like if a document has the word electric vehicle, does it mean that the document is talking about electric vehicle, and what part of the so all of them has to be extracted from those patents or scientific documents. So a lot of processing, we do a lot of processing on that to get the insights, and based on the output of the insights, then we look at the statistics. Okay, is it increasing or is it decreasing? So that way you can get an idea about that. So the first and foremost part is that to extract the insights from the documents. before we do any type of like extrapolation or any type of statistics based on the number of publications. Okay, again, this is just to show you that, like, when you look at a document, there is a wide range of level of processing that we need to do. For example, if you are looking at a micro level, when you see one statement, what can you get out of that? Okay, again, this is the first claim of Edison's patent. So if you look at this particular one, like, there is a lamp involved, and the lamp is emitting light, and light is by incandescence. So again, so the same thing can be represented like this. Again, there are more deeper, like, for formal representations possible, but this is just to shows that, okay, what are the things involved here, and also in between, okay, what does the lamp do? Again, that part is over here, it is not written here. So this way, if you look at one sentence itself, there is a lot of information within that, and can you just capture that? So that is the micro level processing that is required in a document. And on the other side, when you are looking at technology forecasting, you are not interested in one sentence or 10 sentences or 10 documents, or like, there could be, like, hundreds of thousands of documents involved, and or millions of documents, of course, you are processing, and then at the end we are coming up with a number, or, like, some sort of statistics. Here what we are saying is that in neural computing, using neural network models, there has been a steady increase in the number of filings. Okay, so, and that's what is shown here. So when we are saying that, okay, from patents or scientific documents, we made a forecast that, okay, this particular one is going forward up to here. Again, so this is showing only till now, and then we can use a method to expand it further to see whether it is going to go up, or whether it has already reached, or it is going to go down. So all those things, like, we can do that. I'll show you in the next slide. Okay. So so this requires synthesis of a large number of documents, and for each document you need to do a lot of processing to make sure that when we say neural computing, what does it mean by that? Is it like, the keyword neural computing, if it is there in the document, that means that it's a neural computing document? So we need to know much more than that. Like, neural computing, maybe there is a document maybe saying that, okay, this document doesn't talk anything about neural computing, but still that neural computing will be there. No, so just looking at keywords are not sufficient whenever you are processing a document, and try to understand what is there in terms of the technology, or what is there, what are the different types of information or knowledge that are available within that. Okay, again, this just shows different types of processing. Now, so what, again, this is just a screenshot from the system. So what we do over here is that, like, we define what is the meaning of automotive. Again, I think it is a little difficult to see automotive driver monitoring and all. So what we do here is that up to here we know what has happened, and after that we can use exponential extrapolation, or linear, or there are different types of processing possible. And then we say that, okay, in 3 years, again, the way it is coming, it is going to continue for a few more years. So that way you can assume. So that is, again, if you look at what are the assumptions that are going into when we say automotive, what do we mean by that? That has to be defined very well. And the second one is that, okay, what are we measuring here? Okay, how many number of publications are happening with that particular topic or concept, or is there? And then we are assuming that, okay, if it is happening up to here, that way, again, it is expected to happen in this particular way after that. So these are the type of assumptions that we are using in this particular case when we say that trend is like we are forecasting to the for the next few years. Okay, so again, so here I'm going to take you through a few of the a few tools now. So here, what we are doing is that we are looking at okay, machine learning. Okay, so here we have text like keywords or key phrases over here. And then we have over here there are concepts like artificial neural network. So you start with the machine learning, and then you see what are the related topics that are out there. Okay, so this particular one, I'm going to click over here to go to that one. Okay, here. So this is live now. Let me just show you. So you do a search on machine learning based, and then it shows all the other areas that are related to that. Now, for example, like I want to find out. Let me see if I want to find out, what are the documents out there. For example, like if you look at here, there are patent documents related to this, and again published this particular day. Similarly, you can look at scientific documents, related scientific documents. Again, this particular product is free. Like again, explorer.electro.com. Anybody can go there and you can explore. You can look at what are the scientific documents out there, what are the patents out there, and okay. So this. So at the back end of the system is like when you are trying to understand a technology, you start with something. For example. Let me see if I, okay, so let me take augmented reality, for example. You start with the technical area and then try to find out what are the other areas that are related to that. Okay, there are computer vision, augmented reality, for example, computer vision. Okay, let me see augmented reality and computer vision together and explore it further. Again, there are so many different ways you can look at it. And then you go down, then you can find out what type of documents are out there, what type of research is happening in that area, in terms of patents or scientific documents, or or if you have your own documents, you can put that as well. Okay, so this is one way of looking at different aspects of a technology. And once you know that, then you want to look at, okay, so these are different types of topics that are out there. Now let me see how each one of them are going to trend in the coming months or years. So this is a beginning to get an idea about what are other areas. Okay, so this is one, and the other one is, okay, this is like the second one. This is about if you want to track a technology, you start with the technology. In this particular case, I forgot what it was. Okay, I can click on this and go. Okay, it was basically on artificial intelligence. So now what we are looking at here is that, okay, artificial intelligence yearly trend. Let me see what. Okay, so these are the ways the publications are happening. Again, it is growing. Again, the 2020 is not yet over, so that's why you see that. And then you go down. What are the technologies? Which are the companies that are citing these documents? So that way okay, IBM, Microsoft. Okay. So IBM, Microsoft, Baidu, and these are the companies that are working in that area. Then you can come down, then you see that emerging technologies. If you look at image analysis or enhancement, artificial neural network, okay, so there has been a steady increase in this case. So this way, the system, what it does is that it identifies emerging technologies in that field based on all the processing that we are doing. So whenever we put all the documents into the system, we keep on processing to identify different aspects about that. We tag them differently, and so based on that, it comes up with the identifying the emerging technologies for any area, for that matter. Okay, so this is one, and then you go down. Okay, which are the companies working in that field? Okay, so I think must be a Chinese company. So you see the companies that are working in that field, what are the emerging technologies in that particular field, and then you go down, you can find out, okay, computer vision, and similarly image processing. So in different areas, you can find out. Again, you can do that free in tracker.electro.com. You can do that free. So just do that, and then the next one is that in 2016 to 20, in any one of these, computer vision, facial recognition, how was it? Okay, there are a lot of a lot of patent filings are happening on that area. So this way, you look at different parts. Okay, so in fact, let me just go to Tech Tracker. Okay, so this is a Tech Tracker. Now, if you want to look at any technical area, for example, okay, augmented reality, last yearly trend, you look at the trend, again, it will come with the emerging technologies in that. Or monthly trend, you can look at monthly as well as yearly trend. Okay, technologies, citing companies, Microsoft, Samsung, and Sony here. Okay, so a lot of things are happening in application area, machine learning, again, machine learning. So this is an augmented reality, as you know. So augmented reality is used in speech recognition, again, this particular man-machine dialogue. Okay, so you see that. Similarly, when you go down, you can see the companies. So there are some companies here. Again, they recently, Alibaba is doing a lot of work in that area. So this way, you can look at different technologies, what are emerging. Again, at the back end, like a lot of processing is being is done in order to get this one so fast. And here you look at by the way, you can click on any one of these to see which are those documents actually. So if you really want to look at the documents as well, you can see really workspace system, the apparatus and system. So this way, a lot of details are given at the end of it. And in addition to looking at this, if you want to compare different companies, how they are doing, different companies doing in this, you can do that as well. I'll show you that. Okay, so at the end, again, I can save it, I can share it, I can track it. Track means like every month I will, I'll get a report on what happened last month. Okay, so this one, and I will show one more here. So in the same case, like assume that I want to analyze. Let me see which are the companies here: Samsung, Microsoft, and Sony. If I do that analysis, again, same augmented reality. There are so many other technologies as well. Samsung, Microsoft, and Sony. Last 1 year. By the way, we continuously send reports, like we create reports on different technologies and send it across. Like you can sign up for if you are interested in the newsletters, these reports. Okay, so you can look at how many granted patents for each one of them, and where do they file, and what are the technologies, quarterly trend, then in that technology. So each area, for example, if you look at the heads-up display, okay, Microsoft has in the last 1 year, again, since we are looking at 1 year, last 1 year there are 188 documents, patents that Microsoft has published, and Samsung has 154 and Sony 161. Again, if you want to look at each one of them, you can look at that as well. Okay, so so here you can look at, again, Microsoft, Samsung, Sony in each area. This is a comparison. Okay, so this is another one. This is just to give you an idea about it. If you want to like look at, go to tracker.relicro.com. Okay, so this is one, emerging technologies. Now the next one is, okay, so this is our full platform. I understand that Dr. Rajesh had given some demo of some of the features of the platform. So, but again, I will just give you an overview here. So here, what we do is that starting with any technical area or technology, we can create a taxonomy of related or related technologies for that, related to that. For example, like here rendering 3D images as a part of image data processing, which comes under augmented reality or virtual reality. So this way we can automatically create that and modify that and edit it, and all of them we can do. And once we do that, so we can look at okay, year 2014, 15 till 19, and which are the ones that are growing, which are the ones that are declining. You can look at those here. Now let me click on this. I think I have a link. Okay, so here I have already mapped Microsoft, Samsung, Sony, all these 6 companies into that. So you can see the number of filings or publications from each of those companies. Then, okay, let me take you through the details here. Let me log in. Oh, I might have logged in here. Okay, so I'm going to show you how we do that. Like, again, this is the area. This is a what is augmented reality, right? Okay, let me take augmented reality. Do a search. So now what I'm trying to do is that, again, this is going to be a fast one. Like, I'm not going to create a really large taxonomy like what you saw there, but I'll show you that. Again, you see all the documents related to that. There are 40,000 documents in that. Now, if you want to look at quickly which are the areas that are trending in the so you can see that the machine learning, okay, related. So again, we have here concepts like these are using semantic analysis. Like, we are looking at process. We process all those documents and identify what are the most relevant concept within that, and then based on that we are plotting it all here. So this can be done at different levels. For we can look at technology wise. Okay, there are medical diagnosis related, like, again, augmented reality, maybe like that could be that robotic like surgery and all, those all come under this. So you can look at what are the things that are growing, what are the things that are declining, and also we can look at through different filters, like semantic filter, technology wise, sub-technology wise, or in the case of like patent documents, there are classification codes, CPCs and inventive, which are the areas that are more invention related. So here inventive codes means, like, within the document what particular topic is being invented, or what is the area in which that invention is in. So those things are all here. So this is one way to look at, like, quickly we want to look at. And the other one is that the way like we can starting with, again, augmented reality. Now we are looking at a small taxonomy automatically created without spending much time. It shows, again, the whole portfolio or portfolio of documents is put into image analysis, manipulating 3D, editing 3D, mixed reality. Now you go into the mixed reality, you can look at what are the documents or who are the companies working in that field. There is Magic Leap Inc. and Microsoft are all working in that mixed reality area. Okay, so again, so this is not showing the forecast now, but what we are doing now is that, like, we are just we are taking it area, augmented reality, dividing into different subdomains or sub technologies, and now we are looking at an overall what happened, what is happening in that particular area. Now we can look at let me save it as augmented reality. Let me have, I have, okay. Okay, So I have got the augmented reality. Now I'm going to look at how things were happening in this area, like at different areas within augmented reality in year-wise. I'm going to look at that. Okay, this is okay. Let me take this. Again, I can give here itself, but instead of that, since I already have this saved. So what I'm doing is that I'm running it in real time to show you how we look at different evolution of this technology, or which are the ones that are trending in the last few years. Any questions? Feel free to ask me. I cannot see any comments, by the way.
Sir, if you like,
Go ahead.
there are a couple of questions. Yeah.
Yeah.
So one is Mohammed Faris. If the technology forecasting is such efficient, why countries like India are missing technologies like semiconductor manufacturing? We are mostly depending on other countries, and right now, if you look into investments, do you think technology forecasting in India is sufficiently working?
Okay, technology forecasting is only one part of that, right? I mean, if you want semiconductor manufacturing, to have a facility like that requires maybe a few $1 billion to set it up. And now, if you don't set it up at if you don't bring the latest technology, then not many are going to use it, right? So when you are setting it up, you need to set it up in you need to spend the money for that. So manufacturing, I don't know whether India will be ready to spend that much money. That is one. But if you look at the technology forecasting is necessary. Even if you assume that the technology forecasting is saying that the manufacturing, semiconductor manufacturing is the one that we need to spend, or is the one that is going to go high. But if you don't have that much of resources to put in, then you look at the next one. For example, many, in the case of India, like the algorithms or the software, or AI, a lot of mathematics, and so all those areas, you can put an emphasis on that, or policies for that. Certainly, technology forecasting would be very much required, but manufacturing may not be the one because it's very resource intensive. Only Malaysia, Taiwan, and
Sir,
yeah. Putting the effort, money. I mean that level of.
The question is.
Yeah.
Yeah. So the next question is, can we predict the market potential of a technology using technology forecasting? How accurate is it?
Okay. We can, certainly we can forecast, but a proper market forecasting, it requires much more than only the technology. So if you look at what is going, as I was telling earlier, if there is a policy, government level policy itself, there is a chance that may go faster. Now, even if you see the technology, what are the market potential for that particular technology to be profitable, right? So for that, you need to know more about the market. You need to know more about you need to do market analysis for that before we cannot rely completely on the technology alone for a product, or to say whether that is going to be the relevant one for the market, whether it's ready for the market. So there are many other factors involved in that. But that will be the beginning, actually. Like, if you can do the technology forecast, and then you can, you can convince that, and then do the market analysis, and then look at the resources requirement to make it a viable product that will be, valuable, and that can bring profit. So, and then you can, go and try to get investment, and so that's how it goes. So this can be used as the first one in the process.
Thank you, sir.
Okay. All right.
Sir, no further questions.
Okay. Yeah.
You can
So let me.
resume, sir.
Yeah. Thank you. Okay. So basically, what I was showing was that now, when you do this, you can see whether the. Okay. Here I can just color code just to see whether it is growing or not, or you can put the trend and all. So this is the other one. When you look into the to the product, the Relicura product. Okay, so what I have done so far was we are using the patent documents to see whether what are the different technologies under a major one, and then look at whether those are increasing, or whether there's a trend. The trend is increasing or not, and so that's what we have done so far. Now, the other one that we do, is that we bring the scientific documents. We start looking at what is happening in the scientific world, and look at this type of taxonomy, or categorizations of all the latest trend in that area, and then look at whether there are companies are filing in that area, or whether there is a trend coming in that area or not. So that is the other way we look at what would be some of the areas where the R&D resources can be spent, or the product development needs to be made, or or IP patent filing has to be done. So those are all can be done using the same platform. Now let me just go back to our okay. Okay, so basically, if you go to relicura.com, you can see that this is a 10 tracker, relicura.com, 10 track tech tracker, and tech explorer. Both of them, you can start using. Okay, so now let me go back to my presentation. Okay, so I want to spend a few minutes on this, basically just to tell what are the major points. Instead of bringing this technology forecasting at the beginning, I just wanted to bring it up later. Okay, so what do we do in technology forecasting? Basically, we are trying to okay, these are different, I'm quoting from different places, because all of them have ideas that are really relevant. So one is that we are looking at new trends or new technologies. Okay, and now these are all arising from interplay of factors such as public concerns or policies or scientific discoveries. Okay, so this is what technology forecasting is. So now, when when you look at a different from different points of view, again, it is not to predict the future. Again, basically what Paul Safo is saying, that it is to tell what we need to know now to do to take meaningful action in the present. That means, again, the goal is to make some policy decisions or some decisions for the future, based on based on the prediction or not forecast of what is going to happen, what is the probability for a particular technology to happen in the future. So that's what he's saying. It is not to predict the future, but to tell you what you need to know to make meaningful action in the present. Okay, action is going to be in the present. Okay, so the other one, like if you look at it the totally different way, I just put it here. The reason is that so technology forecasting is the way in which persons who don't have full current knowledge of technological changes. This is true because nobody knows very well what is our current knowledge. So that means basically what it says is that, like, whenever we are going to predict, the prediction is going to be based on our current knowledge, and our current knowledge itself is not complete. For example, like if you look at the documents, all patents and scientific documents that have a lot of knowledge out there, even if the knowledge is there, if our mining or if our system is not able to get what is there, even that itself is not sufficient, right? I mean, even if you get all of them, still there are missing. But so what we are trying to do all this, I mean, everybody is trying to do is that based on our current knowledge, that itself is not complete. And now what are we doing? Predict currently unknown developments. Basically, so we don't know what is the type of developments that are going to happen. Again, that is going to be like based on scientific discoveries, like that disruptive technological developments and all. So we don't know what is going to happen. Okay, so but still we need to predict it. We don't have a way to avoid this because we need to do a forecasting. Basically, we need to forecast it, and then, based on currently unknown factors, there are so many factors. For example, like if for example, like if like when Elon Musk came up with the electric vehicles, right? At that time, like it is just one person, like just came with a mission, and then the whole automotive industry got affected with that. Like with the Tesla, like the development of the Tesla, the growth of the company, and so the whole thing got affected. So basically, there are so many, like so many factors we don't know that can completely change. Again, that the factors don't need to be just government policies. The factors can be like an entrepreneur, like Elon Musk or Jeff Bezos, deciding about going everything to like online, and so just a few entrepreneurs, or like so making some decisions, like so many factors are there, and then currently unknown technical trends. So basically, we don't know any one of this, but still we need to forecast. But still, that forecast is important. So still, as I was telling earlier, like technology alone is not sufficient for a product, like whether the product is going to be a good fit or not. But if you don't have anything, like so this is something basically what we are saying is that this forecast is not going to be completely true, but still we need that. There are so many factors affecting that, but still we need that. Okay, so that is one. The other one is the Yonggi Cho. So what he is saying is that the forecasting refers to the analysis and evaluation of performance parameters, timing of advancements, basically new concepts, products, and processes, market penetration, and sales in a given time frame. Basically, the every forecast, like we can do 2-year forecast, or we can do 10-year forecast. Like, for example, whenever policies are being made at the national level, it is based on like a 10-year like type of time frame. Okay, so in a given time frame, timing of advancements, new concepts, products, processes, market penetration, and sales in a given time frame with the probability statements. Again, we don't know. So again, we need to give some quantitative measure of what do we believe in that on a relatively high confidence level, basically probability or confidence was, which anticipates opportunities and threats from technological changes. Okay. These opportunities and threats, basically, when you see this one, we don't need to worry about it. For example, whatever is happening as a threat for a larger organization could be an opportunity for a startup. And that's how, like, most of the time these things work. Like, if you look at the S curve that I was talking about earlier, so the first technology goes back to, okay, let me Okay, this one. So if you look at the most of the time, what happens is that this evolutionary one. This is like larger organizations are mostly following this initially, and then like smaller companies will become larger later. But so what happens is that like some of the employees of the companies or some of the others following that particular technology, they come up with ideas and they start this particular one. So now, if you look at this disruptive technology is a big threat for the larger organization, but that is a great opportunity for startups or smaller firms or entrepreneurs where they can like they don't need like they're not looking for this much of performance and this much of profit. Basically, they can fill this one with investments from others or by show or or other ways, basically. So it is an opportunity, is a threat for a larger company, but it's an opportunity for a smaller one. So let me just go back over there. Okay, so anticipate opportunities and threats from technological changes in order to provide for more well-informed R&D decision making. Okay, so these are all showing like different aspects about technology forecasting. It is not going to be like there are a lot of unknowns. What we are trying to do is to reduce the unknowns as much as possible, get as much as knowledge as we can from existing knowledge base that are patents and scientific documents, because most of the technical developments will be based on existing knowledge anyway. So that are already there, but so that is there, and there are a lot of factors that are going to change technology forecasting, but still we need to do it. And even when we do a technology forecast, and based on the policies can change, and when the policies change, based on that, it can affect the technology forecast or technology itself. We can change the trajectory of that as well. Again, so these are the ones I have, and then this is just a summary. Objective of technology forecasting. Again, this is to make policies and decisions in the present time. Today means in the present time. Again, policies at the government level, decisions at the company level or organizations level. Okay, it is critical for, it is not just for nations, it is for businesses and business and communities. There is interaction between all of them: forecasts, policies, missions, and scientific discoveries. All of them are connected, and then social market related ones will also come into picture. But disruptive technologies bring threats and opportunities and are harder to forecast. The reason it is harder to forecast are that when we say that this is a trend, by looking at when you are looking from today to the past, and then we are trying to interpolate, that is easy to do, but disruptive technologies are not. We cannot do that. Or we might be able to do that at a later time when we are able to actually get all the technologies into the machine, and then we can start processing. For example, if you look at the interplay between different technologies, when one technology improves, it can it will have an impact on the other one. So all these things, it is currently, certainly at least in the next many years, is not, I don't expect that to happen, but but those things, once those come, basically we may be able to systematically do that. So currently what we are doing is that we look for any indication of a technology that is coming, that could become disruptive, and based on that we analyze it further. Again, that is harder. Okay, so mining technical documents, basically, if you look at all the technical knowledge out there, even there is a say that basically, at least 75-80% of the entire technical knowledge is available within the document, within the patent documents. So we we have a lot of information within that, valuable insights. We can get it on evolutionary, and also it is not just on evolutionary and or disruptive. Only problem is that it is hard to combine them to find out what could be a disruptive technology, but it is out there. That okay. So these are the ones I have now. If you have any questions, otherwise I can take you through some of the other products. Any questions, anyone? Let me see how I. Radesh?
Yes, sir.
Sir,
I can
there are
hear
some
you, sir.
questions in the chat box, sir.
Oh, in the chat? Okay, 1 second. Let me see if I can. How do I need to. Oh, so, okay. Okay, 1 second. Okay. Okay, there are questions here. Okay, to pretty market potential company. I don't think there are any questions, right?
Yeah, I think, sir, you have addressed some of them. I also was not actually there. I just lost my internet connection. I don't know, in between, in the last 5 minutes,
Oh,
So
okay.
no questions
any
are there,
questions
sir.
have been asked. Vijita, hello.
No questions are there in chat box, sir.
Okay. Uh, Sir, just one. Maybe I have a question. I wanted to know. I mean, is it appropriate to follow the market forecast and then look into technology forecasting, or should it be the other way around? Which would be more ideal?
Okay. So market forecast and technology forecast. Yeah, I think if you like it depends upon what your goals are, right? So if your goal is to have a, a, a company or a startup or something like that way, then I would say that you need to look at the market and then look for the technologies that are relevant for that, and then go and get the technology. But if you are in an organization, let's say large organization, for example, or R&D firm, then you need to look at how the technology is moving, or how the and then go in that direction. So it depends upon which direction, what is your goal, right? So depending upon on that, it would be will be different.
Okay,
So
sir. By goal, do you mean the financial goal, or is it something else?
okay, so when you look at when you look at forecasting something, right? So when you are forecasting something at a corporate level, you are looking at removing all surprises and identifying what new things are going to come, basically to build your next product or next services, right? So that is your goal. Now, if you are an R&D organization, the it is not the monetary one I'm talking about. For example, we have worked with like policymakers. So the goal of the policymakers, at least in one case, was that they have an industry that they need to make sure that they are the top of that. They are the top in that particular industry. They need to remain that way. So then their goal is to find out what exactly is going to happen in related technologies, and so that like they can make the policy around that to keep at the level of at the top level. So so that way, so that in that particular case, it is not the market that they are looking at. So market is secondary in that case. It is like the technology is going to change, and it is going to bring down their industry. Like they are going to go down. So they need to find out what is going to happen in terms of the technology, so that the policies of the government can be made to increase the number of the research that is happening in that area, or products that are happening, or technology development that are happening within the country. So so in that case, certainly the technology forecast is more important than the market forecast in that case. Okay. So
Thank you, sir. Yeah,
yeah.
thank you for the clarification.
Yeah.
Sir, so I think we have
Yeah.
no further questions, but if you
No,
would like
no,
to,
Radhi sir, I
sir,
have a
Rajesh,
question.
yeah.
Sir, you have shown a picture in which in the graph there is a change in the technology versus time graph.
Right.
So in that you have shown that there is a jump is taking place. So whether the jump will first it will come down and then it will go up, or is there any pattern for that kind of a variation?
Okay. So you mean this particular one?
Yeah, that disruptive.
This one, right? Okay. So if you look at what this is happening is that okay. So like in this particular technology, again, better and better processes are happening. So like they are able to improve the performance of the product. For example, like if you think about maybe like increasing the number of data rate in a wireless communication, as an example. Okay. Or number of chips within per square inch, as an example, right? So they could increase this one that way, right? So now what is happening over here is that like when I don't know whether that will be a specific one. The like if someone came up with a better process where the like in the case of a chip, semiconductor chip, like they are able to increase the number of like a different way of putting putting the transistors, right? So if so this is not continuous. Like they come up with a totally new technology, but reaching the same same goal. If it is a wireless communication, for example, like the goal is to get exactly this like the data to be passed through wirelessly, but you are coming with a new way of doing that particular one. In the case of chipsets, for example, like you are looking at, so you want to increase the number of performance, like for example, like number of multiplication additions and everything, right? So this particular one is a very different technology achieving the same goal.
Yeah, so you are saying that in the evolutionary, when it reaches a saturation point, there can be another method which can create an exponential increase, and it may not be having the same slope.
Yeah. So yeah, it won't. Yeah, that's right. So again, just think that this particular one is just for a demonstration only. Basically, this will not be like this. This will be like very non-smooth. I mean, like it can vary very differently. Like this slope may be different from this particular slope. Yes, that's right.
Okay. Yeah. Okay. So it can be actually the new technology can start from other performance level also, but between that the filling of these old technology and new technology will be taken care by the startups. That's what you are saying.
It can be. Mostly startups look for this type of an opportunity, but what larger corporations are also doing is that they will have they might start a new business or a team to work on this particular technology by putting some investment into that, like we call intrapreneur, or so that way, like internally they can start a startup also within a company. But this type of, like, in order for this to happen, many things have to come into place. One is that the scientific discoveries in related areas has to be tracked, like, so that those are the ones that will be converted into a technology that will be implemented into a product, or and it will become valuable for a product, right? So that one is the one that is being tracked by large companies as well as small startups. And more small startups, especially the startups, the key people are working in a company like this, or are working in a specific area like that, so they will be the one that will who will identify this type of a disruptive technology first. And, like, so that is what everybody's goal is.
So, I heard in one of the webinar, like earlier, the old technology was black and board, and the new technology is online education. So, the disruptive technology is the one which develops some applications like Zoom, Google Meet, etc.
Right.
Yeah. So we can say that kind of a method.
Yeah, so that's also true. Only thing is that if you look at the technology, like in this particular case, I think Radish's question is really true. In this case, what happened was a Zoom again had so many, like in WebEx, and there are so many companies.
Okay, sir.
And then all of a sudden we got an opportunity for the got an opportunity during COVID, like everybody's home, and so they immediately captured it. So that actual technology was there, but the market dynamics, or the social dynamics, changed the outcome from that technology.
Thank
so
you.
This is happening in every technology all the time. Like, one is going to saturate and another one is starting. Only thing is that you need to keep an eye on that, and that's what they do.
Yeah, we should find a room for improvement, right?
Yeah, right. Whenever you find a room for improvement, and the room, so the one difference in between this and this one is that here there is an improvement. For example, they may find an improvement so that it goes a little higher. Okay, so that is still, it is incrementally, you can predict that, as it is going. But here it is a totally different paradigm, or a totally different type of a technology, or one where it immediately it is actually, if you look at here, this is not as good as the other one at this particular point, but the other one is always slowly keeping up, incrementally. But this is, so that's why it is hard to find, hard to detect.
Okay, sir. Okay, thank you very much.
Yeah, sure.
Yeah. So if there are any questions, you can unmute your microphones and ask, and post it directly to the resource person, please. Sir, so if you want, sir, you can maybe tell something about the products that Religura offers, since
Okay, yeah.
I don't find any questions.
Yeah, thank you. Okay, so let me take you through some of the. As I was telling you, so Relicura is fully focused on technology, technical documents all the time. Now, if you look at, go to Relicura, you will see that there is something called COVID Analyzer, for example, here. Now, COVID Analyzer this is just for COVID researchers. You can go over here. You do any, you can look at what is happening in a in different areas here. Research articles, antiviral drugs. Okay, so now you know that so in antiviral, what are different areas, and then in each one of the cases you can, again, this is free. I mean, these are all free products. then you look at what are the latest ones and like click on that and read about that. So this is one. The other one is that like we have inventor index. Now assume that you want to look at an inventor and look, okay, Tesla, for example. You click on that. Now you can get all the patterns from Tesla here, and then you can create a report. And this report can be shared with others. Like if you're like for inventors, these are like like it gives a report on the impact or their invention. Like he has 22.49. So this is similar to H index in the academia, where you look at the impact of your research in the academia. So similar to that, this is I index, like an inventor index. Now, when now, if you are working in technology areas, like I would suggest you to like go over here and use it. Again, there is like you don't need any. You can sign up for free. Even if you don't sign up, you can look at some of the companies or technologies for here. Now, if you sign up, there are a larger number of companies and technologies that you will be able to analyze. Here I have signed up. Now, if I want to look at companies like, let me see, okay, let me see, Amazon, for example. What did they do in the last 1 year, or what is their trend or monthly trend? Let me just look at monthly trend. Okay. Okay, so this is like month on month, like we are looking at how they are filing, where they are filing, and all the documents and technologies. Which are the companies that are using IBM, Microsoft, Zoox? So these are the companies that are citing their patents, and these are the areas they are emerging from them. Again, these are based on patent documents. Now we are looking at network integration, or here if you look at distributor across, like distributor application in the network. So this way you can look at what their focus is, what are the emerging ones, and like again here. And if you don't find a technology or company, then you can just put a suggestion. We can add that. So you go there, you look at the document. So basically, the information is available to you. The way this works is that if you want to have your own customized ones, then you need to have a paid subscription. Otherwise, we are providing a lot of technologies, a lot of companies into this through this tech tracker. And at the end, so let me show you this. So AI so they are doing a lot of work in AI, deep neural net conversion. So these are all the areas like they are working on. Now we can like I can share this. It's like if I click on this, we can get a link, and this link can be shared with anybody. So once you send it across, when they click on that, again they will get exactly the same report. So this way, so what we are doing is that we are creating this type of reports, and we have a lot of subscribers to our tech tracker, so for our newsletters. So we plan to continuously send technologies after technologies, like so that you can keep up with what is happening, what is emerging technologies in this area, and also for what are the emerging technologies for a company, or what are the emerging companies for a technology. I mean, all of them, like can be monitored through that. Okay. And yeah, try try it out. Then the other the Tech Explorer. Where's the not here? Okay, so the Tech Explorer is used by the academic community the most. Now, if I I can sign up here. So as I was telling earlier, whatever be the technology that you are interested in analyzing and exploring, you come over here, you give the name of the you start with a keyword. Let me see if I do coronavirus as an example. You start with anything, and then you can do. Okay, now this is coronavirus. So what are the other things that are related? For example, coronavirus, okay, the vaccine. Okay, let's look at coronavirus and vaccine related, explore it further. So this way, so that is one way to do that. Or if you find that, coronavirus and, okay, let me see if I don't want, I want, okay, what is this? I don't see any relation at all. Let me see if there is something to do with this. So coronavirus and gastroenteritis, I explore. And now if you go down, let's see what type of work has already happened in that area related to those. Okay, so you can see that you may not think that, no, okay, this has anything to do with this, but now you can find out. Okay, so this is really so there are work related to that. Okay, this is again treatment and everything. So you can so this way some of the things that you may not even expect that something to like that is possible, but again you will see how these are all related. So the idea here is that you start with the technical a keyword or key phrase or technical topic and explore it in different directions, and then you come back. For example, you don't want it that direction, or if you want to go in another direction, so you come back and so that within a few minutes you get to see what are related areas. Like even research, I mean, like the researchers come to us saying that they some researchers working in that area for years came up with telling us that they identified areas that they didn't know that it was related. And then it is not just we are showing that one. In addition to that, we are showing the actual documents, patents or scientific documents related to those areas. So this is something that you can you should try it out. Again, this is also free, but if you need a account, then if you have an account login, then bring your own documents into the system. Okay. So you have a lot of scientific documents or technical documents, for example. When you bring it over here, the system will automatically categorize them into different areas. For example, if you look at this is put into circulatory system, computer simulation. And now if I look at I have different ones here. For example, generative adversarial units, machine learning, artificial intelligence, 100%. Okay, so this way, basically, you can look at, you can bring your documents, and now if you do a search in an area, then you will see your own documents also coming with. So basically, this is an area. This is a product that you can use it to manage your own personal collection of documents, as well as searching patents and scientific documents, and exploring related technologies and others so that is the Text Explorer is for. The other one, I don't know whether you're IP focused, then I can take you through the really deep one. For example, when I did this particular search, we can do a lot of things. Let me show you this. This is our full platform where most of the things, whatever we are showing over here, you can do that, but it is not it is much more comprehensive. A lot of, you can go through a lot of depth in the analysis. So this is being used by most of the corporations, IP departments of the corporations. let me. So Radish, yes, you have gone through some of this, right?
Yes, sir. Yesterday I did go some of these. Just
Okay.
maybe one feature I took in coronavirus and landscape, and then looked into some of the sub technologies, subdomains within that technology, and
Using
uh,
taxonomy.
so no, I didn't look into the taxonomy. I just
Okay.
looked into probably the domain areas and those things.
No, okay. So domain names and all. Okay. Yeah. Okay. So the other things are like, so if you just look at it, so I did augmented reality, for example, and then like looking at what are the topics in which are related to augmented reality. Let me just bring it up. Yeah. Okay. Okay. Yeah. I don't know why. So whenever you do a search, I'll find out what exactly. I think I'm doing something. Like if you look at, so like so again, this particular one is our search on augmented reality. Now, if I go here, we can look at all the companies that are working in this particular field, or we can look at what are the areas, technical areas, sub technologies that are related to augmented reality. So something is happening on my computer. I don't know why this is not coming up. I think I'm. Huh. So this is the taxonomy. Now it is not just a taxonomy. Like whenever you create a taxonomy, now assume that you want to create just a report based on this. Like you click on the report section, then it can automatically create a landscape of in one go you can get a landscape, like technology landscape, create a report based on that. The idea here is that you start with the technology, create a taxonomy. Again, this taxonomy I can create much bigger level, but this is a simpler one, quickly created. Now if you look at the summary, okay, Magic Leap is a major one. There are companies acquiring this pattern. RPX is acquiring patterns. Now technology trends, you look at the type of growth that is happening. Now, which are the technology, which are the companies that are, again, patents and patent holders are all here. Now, how different companies are doing in technology-wise, company ranking here. Magic Leap is good in topper here, and here. The color code, you can look at the color code. So Magic Leap is a major one in, it looks like in augmented reality. So this way you can look at all of them, and then also we have a way to look at the quality of the patterns. Like there are like 5-star rated, like the high rated patterns are here. Different companies, colors are for different companies, and this is star rating from 0 to 5. So at the end, you can look at who are all buying patterns. For example, this particular company sold to RPX 114 patents in this area. So when you see that a lot of patents are getting bought or or transacted this way, you know that that area is hot, basically. So if you have an invention in that area at that time, there is a high chance that you will be that those will be worth more. So again, here roles from roles to Amazon. I don't know whether they bought the company or they bought only the IP. Okay, so at the end you can do a preview of the entire one, and then
Sir,
yeah.
I just have a question. Sir, can we also get the licensing information, licensing of patents from this?
Uh, no, licensing information is mostly it is not public. So we can get only public information, right? So licensing is between two companies, but when they change the right to someone else, they file it in the patent offices, and then once they do that, then we get, that's it, for public information we get that. But if two companies have jointly licensed or some agreement between those companies, we don't get that.
Okay. So, sir, because in India we find that in Form 27 they normally provide this sort of an information.
When they you mean when they sign an agreement between the companies, licensing?
Yeah, for commercialization. So once a patent is granted,
Yeah.
and every year you have to provide commercial working of the invention. So if it has been sub-licensed, then we need to provide to whom it has been licensed or sub-licensed.
So you get it from the patent office, or is it yeah, like an SEC filing type in the? Okay. Yeah. We don't. I don't know about that one, but
It's available on the it's
oh,
available on the websites and in the
okay.
patent documents.
Okay.
Normally
So that
have this
means basically
information.
maybe there's a requirement
Only this
that.
is available only once the patent is granted.
Okay. At least over here, only if there is a reassignment of the patent to someone else, that is when it gets
Yeah, in the Indian law.
recorded in the US. Yeah, and also here we can look at detail.
Um,
If you go to the original patent, if you go to assignment, we can look at for example, in the case of augmented reality, we can find out all transactions, so all reassignments are available here. So the first one, the taxonomy and creating the report, that is one-click report. But you can go into the details of every one of those through other means. The buying and selling will be available from the assignment and search. And also, if you have if you want to look at the non-technical literature that is available in over here, migrating the current search into one, or if you have private documents, there are companies using the private documents for bringing their prior art, or invention disclosures, into their own area within Relicura. So if you do that, the advantage is that you can all our processing will be available to them, all the processing of the taxonomy creation and all of them are available, and they can search and they can go back and forth between private documents and all. So these are all available within Relicura. So there are 40,000 documents.
Fine, sir. So shall we?
Yeah.
Do you have anything else to add, or shall I?
No, I think yeah. Thank you for giving this opportunity, and it's good. Good to see that this type of programs are going on over there, and yeah, um, yeah. So good to see that. Now, again, if you have any questions, just write to. You can write to me. If anybody has any questions, and you can write to me, george@relectro.com. Okay, then.
Fine. Sir, I'll request Lakshmi Menon, research scholar at IUCIPRS, to kindly propose the vote of thanks. Yeah.
Dr. Rajesh,
Lakshmi, are you there?
I would also like to say a few words of thanks. Hello?
Professor.
Yeah, hello?
Yes.
Yeah,
Dear
sir,
participants,
please, sir. Yeah, sir.
Mr. George has joined us from California and to bring in this perspective of how information technology is being used to disseminate and make technology forecasting and the technology landscape more fathomable, understandable through a few clicks. A lot of effort has gone behind development of the software package Relicura, but in our country, it is not put to as much use as it can. And there was a question from one of the participants, are we doing technology forecasting well enough? Today, when the level ground is available with the use of technology, IT, for anyone to do things like that, then our staying away from such technologies, not understanding it, not harnessing it well enough for our own research, development, and technology progress is unforgivable. I place on record my thanks to Mr. George for joining us and taking the pains out of his love for his country to make this product available here to researchers and to others so that they can also get the benefit which developed countries are reaping. Thank you, Mr. George.
Thank you, Professor Dasi. Really appreciate that. Thank you. Again, thank you all for joining, and thank you, Ratish.
Thank you, sir. Thanks a lot for joining, and we hope that we'll need your support for conducting more such programs. So we
Yeah. All right. Yeah. Thank you.
We definitely expect your support. Thank you for taking the pains to join from across California during this time.
Yeah.
So we break for tea, and we assemble at 11:10. I request all of you to join by 11:10, and we'll start by 11:15. So thank you all.
All right. Thank you. Bye-bye.